Raise the roof, roof, roof.
Okay, folks, this time we're going to look at Newton's second law, first law, where the sum of the forces equals 0. Newton's second law, once again, has the sum of the forces equaling something other than 0. Now, famous Newton's law, sum of the forces actually equals the mass times the acceleration. Okay. Now, I left something out here, and you could actually break this down into 3 separate dimensions, okay? And it's very valid. So the x direction, the y direction, and lastly, the z direction. Now, I'm going to tell you right now, we don't actually deal with the z direction, okay? So this is what we're dealing with right here, okay? So the simplest example of Newton's second law is, let's say we have a box on some wheels. Let's make it a really big box. So here's my person pushing it. Let's say they push with a force of 100 newtons. It's positive because it's in a positive direction. Right? And the one assumption we make, okay, is that you have absolutely no friction. Okay, so we're going to have no air. We don't have any friction in the bearings of the wheels or them actually rolling along the floor. So there's no friction pushing against the box. So if I was going to look at the sum of the forces in the x direction, it would simply be equal to positive 100 newtons. Okay. Now let's take a look at the y direction. In the y direction, we have the weight. We can make up some value for weight. Let's say 200 newtons. It's going to be negative because it's in the negative y direction. In this picture, do I show the crate falling through the floor? No, I don't. Okay, so the floor is strong enough to support the box. So the floor pushes up with the same exact force. That force we call the normal. Okay? The normal, by definition, at least my definition, is the amount of force the ground is pushing on an object. Okay? So in this case, the weight of the box would be 200 newtons. That means the normal would have to be positive 200 newtons. Okay? So actually, the sum of the forces in the y direction would be the weight plus the normal. And if I take a look at that, it'd be negative 200 plus a positive 200, and that would equal 0. Okay? So is the y direction actually Newton's second law of motion? No, it's actually the first, okay, because the sum of the forces equals 0. So in this case, when you look at all the directions, the x and the y direction, Newton's second law is satisfied in the x direction, okay? Now we could take this a little bit of a step further, and we could actually relate that to the kinematic equations. And I'm going to show real quick how this relates. All right. So the kinematic equations, if you remember, and I hope that you do, would be VF equals VI plus AT. VF squared equals VI squared plus 2AX. Now this is for the x direction. We could talk about the y direction later. And x equals VIT plus 1/2 AT squared. Okay? Now before, we called these kinematic equations, and we use this to talk about motion without regards to its causes. Okay? So kinematics basically looks at these equations. There's nothing that actually shows why an object is moving, or how it got started moving. Just the fact that it's moving and it's accelerating, or maybe even staying constant velocity, or we're trying to find how far it went in a certain amount of time. Now we're actually dealing with dynamics. Okay? And dynamics looks at more than just acceleration and velocity and time. It actually looks at the force, and it tells you how the object's moving. Okay, the object's moving to the right. Well, why? Because I have a force on it. Okay, that's why. So you can see here that we actually have a link between dynamics and kinematics. Okay, and if you look at it, I think it's pretty simple here that you would come up with a link. And that link is right here, the acceleration. Okay? So we could look at problems two different ways. Okay? Maybe we're given the velocity and the times, and we have to find how much force was applied to an object. Or maybe we're given the force, and we're asked, okay, what's the final velocity, or how long does it take to go 50 meters, okay? But now we actually have a reason or a cause to the motion of the object. Okay? All right. So if I were to look at Newton's first law and second law, and I wanted to sum it up, okay? And really two points, one for each. Newton's first law deals with balanced forces. The second law, of course, then deals with unbalanced forces. Okay? So we have sum of the forces equaling 0, and then we have the sum of the forces not equaling 0, which means they're unbalanced. Okay. That's a quick introduction to Newton's second law. We'll get into some example problems here, and we could have inclines and flat surfaces and those sort of things. Okay, and that's what we're going to look at in the example problems.